Go ahead and get out your notes. We are going to talk about the shell method. What have we not done with our shell method?
Over something that isn't an axis.
Okay, a non-x or y axis. Looks like a lampshade,
It's like a
doesn't
dog
it?
food bowl. Or a lampshade.
Oh, it is a lampshade.
Definitely a lampshade.
Okay. What is going to change, do you think, about doing the shell method over a non-coordinate axis? The radius is going to be different, right? Okay, the height of our rectangles, we're still going to calculate the same. We're still finding 2 pi r h times the thickness. What's going to be different is our radius. We're going to have to think a little bit, okay? Good thing it's Friday and our brains are nice and exercised.
Who's Brian?
Okay, so here we go. In this picture, this is our original piece. There's no R up there, so hold on. Okay?
R is that line?
No. Hold on. Okay. So our height. Okay, let's talk about our height first. What is the height of our shell, each shell? F of x minus g of x. Okay, that does not change. What changes is our radius. What you always need to think of, okay, and I've been trying to verbalize it with this when we were talking about just our coordinate axes. How far away are our rectangles from the axis of rotation? How would we describe this radius?
A minus C. Or X.
Okay, we're going to say x. Okay, why do we say x? Okay, we have rectangles throughout this entire little piece, right? And so at any given time, that rectangle is x away from the axis, okay? So from our axis of rotation, in this case, since our axis of rotation is on the right, this whole right minus left business, okay? A minus x.
So if it was the original was the one on the right, it would just be x minus a.
Right. Did everyone hear Rena?
Yeah.
Okay. If this red was our original, then our radius would have to be x minus a. Okay. So we're going to do examples. This is the way we're going to get better, right? We're going to rotate 4 minus x squared, x is 0, y is 0, that region, about the line x equals 2.
What is 4 minus X squared?
Y equals 4 minus x squared. Okay, so here's x is 0, here's y is 0. 4 minus x squared is a parabola that has been flipped upside down and then up 4. Where does it cross the x-axis?
Negative 4 equals 1.
Negative 2 positive.
That's what I had. I'm sorry.
Okay. There's our region. We are going to rotate this about x equals 2. Sorry. here we go. I'm going to draw in our rectangle that has thickness dx, shell to our axis of rotation. Okay, shell method. Shell method is always 2 pi RH times the thickness. So here's my 2 pi, our radius. What is the distance from our axis of rotation to each rectangle?
2 minus x.
Okay, here is the radius right here. We're going from 2 to any given rectangle. So 2 minus x, that is our radius. The height of our rectangles would be what?
4 minus x squared.
4 minus x squared minus 0, right? Top minus bottom, we don't need to write the minus 0. Our thickness is dx. So we have 2 pi RH times our thickness. We're summing all of these shells up from 0 to 2, because those are our x values that our region covers. Okay. Do you see how these algebraically could get a little messier when our axis of rotation is not an axis? Okay. If we wanted to do this by hand, we would have to do what? Okay. Foil, if you were to distribute, however you want to think of it. Let's go ahead and put it in our calculator.
2 minus x squared times.
What are you?
I was factoring it and then squaring it. 2 minus x quantity squared times 2 plus x.
40 times x.
Any questions about our setup or our picture? Wonderful. All right, the region enclosed by the x-axis in the parabola. Oh, f of x equals, that's unfortunate. 3x minus x squared is revolved about the line x equals -1 to generate a solid of revolution resembling a bundt cake. What is the volume of a cake? All right, 3x minus x squared, what does it look like? It's an upside down parabola intersecting the x-axis where?
At 0, 9.
Our vertex would be at 1.5, right? In between 1.5 what? 3 halves, when you plug in 3 halves.
3/4. No,
3/4?
I won't say it's 3/4, but I think I'm wrong.
That sounds wrong.
Okay.
Great job.
What is it? Thank you, Lena. Okay, so here is the line x is -1, and Here's our region. We get a bundt cake. Not a very good representation of a bundt cake, but you get the idea. Okay, so we're going to put in vertical rectangles with thickness dx, which means we are creating shells. Okay. So 2 pi RH times the thickness. What is our radius? When you think of radius, before you answer, I know some of you know the answer. When you think of radius, you need to think, how far away are our rectangles from the axis of rotation?
Negative x. X plus 1.
Okay, x minus negative 1, right? Right minus left, x minus negative 1. Or if you want to think of it, well, this distance is x that we were doing yesterday, right? Well, we've done one more. And whichever works better for you. I like the right minus left, so these are all at any given x minus our lines at negative 1. Okay? Times the height. What's the height? Your x minus x squared minus 0 times our thickness. Okay. Now, before you start complaining about the algebra that would be involved to integrate this, let's think about if we drew horizontal rectangles to create washers. What would make that difficult?
There's no one equation you can use, like, you have to use a positive and negative.
Okay, square root. We'd have to solve for x, wouldn't we? Who wants to solve for x?
I tried that on the quiz and couldn't do it.
Okay. The washer method would not lend itself to be efficient. Even though we're gonna have to do some algebra here, the washer method, okay, solving for y, that's not good. Or solving for x, excuse me. All right. What? All right. Oh, we forgot something. What are our limits of integration?
1 to 3. I mean 0 to 3.
0, 3. Okay, find me the volume of my cake. With your calculator.
I mean, donut.
The cake
45 pi
pi
over 2.
Oh, what?
45 pi over 2.
Never
mind.
He's wearing a math shirt.
Seriously? What if somebody sat there and pointed at you from across the room? Next one. We test our graphing skills here, don't we? Okay. This is a question that some of you, or this is a type of question that some of you struggled with on your quiz, right? Graphing that x equals y minus 2 the quantity squared. Right? First of all, where does this, which way does that open? It opens to the right. Okay. Which way is that shifted?
Down to.
Left to.
Down to.
Okay, let's think of this in x's and y's.
Yes.
If that was y equals x minus 2 squared, which way would it have shifted?
Right. Right.
Okay, so now let's think of it x equals y minus 2 squared. Which way does that shift?
Down.
Up. that, if that was y
Because it has to go to
equals,
a positive axis, right? Yeah.
Okay.
Gotcha now. Yep. Alright. I was not understanding before. I'm understanding.
opening to the right. Okay? If that confuses you, and, or you're not sure, okay? Well, if, plug in a point, okay? If you plug in, we know that this is shifted either up or down too. You guys were kind of not sure, right? Well, if we plug in 2, we get 0. Or if we plug in -2, -4 squared, which is, you know, which is not on the axis, okay? So, you need to think of that. There's that to help you. Y equals X. Where is this intersecting at? 1, 1. Four, 4. If you're not sure, or if you did not do it algebraically, I would plug it in. 4 equals 4. 4 minus 2 squared is 4. So they both work, right? All right, we want to rotate this region about the line, what? Okay. What kind of rectangles will we draw?
Horizontal.
It's a good thing we're drawing horizontal rectangles, isn't it?
Yeah.
What would happen if our rectangles were vertical? We'd have to have 2 different integrals because our top and bottom function change, right? So it's a good thing we have the shell method today, isn't it? Okay, so these have thickness dy, right? So now we want to, 2 pi r h times the thickness. So there's 2 pi r, our radius. What you need to think of, how far away are all of our rectangles from our axis of rotation? Y plus 1, okay. We think of these as y away from the axis, minus, our line is -1. Y minus -1, we're going to write as y plus 1. The height of these rectangles.
Is right myself. So x minus y minus
Y minus
1 minus 2.
times our thickness dy. Our limits of integration. Now, even though this algebra would be a little meticulous, okay, it's possible, and it's easier than integrating twice and solving those for y, right? But I will let you use a calculator to help me out.
63 miles per hour.
You are on top of it.
Okay. Right now.
Okay. How do you feel about things?
I'm not getting the integral and stuff anymore. So I mean, yeah, that's a step up. Yeah.
Getting what mixed up?
Not the integrals. Like, so like, cause for the disc,
Like range.
for the disc one, we would have had, it would have been dx if we're going over a horizontal thing, or now it's, I'm not getting it mixed up.
Okay.
I'm on board.
Okay. Even though you all giggled when I said parashell and perpendicular, it really helped. I even have some of my Calc 2 kids, when we went to do a problem, they're like, oh, perpendicular.
They do the robot arms too.
Out of all people, I thought you would be the one not to mock me.
No, it wasn't.
Aaron, sure.
It wasn't mocking. I'm sorry.
I see how it is.